Alright, here's our video today on parallelograms, and specifically we'll talk about general parallelograms, the ones you're familiar with, some of you, as just calling a parallelogram. But there are four parallelograms, there's four types. A rhombus is a parallelogram, a square is, and so is a rectangle. But we're just going to consider the one we just say parallelogram, and we call it a general parallelogram. So I have my pen here, I'll just say talking about general parallelograms, not admirals. Right? And one thing we should know, some rules, parallelograms are quadrilaterals. Quadrilaterals have four sides, so we should know that, right? Quadrilaterals, and you know this, have four sides. So quadrilaterals can be a trapezoid and could be a deltoid, which is a kite, but deltoids and trapezoids are not parallelograms. Parallelograms have to have two sides that are parallel, at least two sides that are parallel. Opposite sides will be parallel and equal in length. Trapezoids don't do that. Or a deltoid. So quadrilaterals have four sides and all the sides, all the angles will sum to 360 degrees. Very important to know. Also, very important to know to solve problems is the opposite side angles. Let's say that's 60 degrees. Well, if that's 60 degrees, the opposite side will be the same, will be 60 degrees. And since it's a 360 degrees, the total, you can figure out what that angle would be and what that angle would be. What do you think it would be? Well, 1660 is 120, right? And so we're missing 240 degrees, right? Because we need 360. So 360 minus 120 will tell us we need 240 degrees. And so if we just say that this is angle X and that's angle Y, well, they are congruent. So we have to divide 240 into 2, and we get 120. So if X is 120, this whole degree here, then Y is 120. And the total would be 360. Keep that in mind when we look at questions. So it's important to know that the diagonals will bisect each other in the center. They'll bisect each other, diagonals. But diagonal AC will not be the same length as diagonal DB. They're not the same length. But they will, when they bisect though, they'll be bisected where each piece is the same length. So AE, let's get my pen working first. This is a question I'm going to talk about in a minute, but let's go back. So AE going into the center, let's say that's 5, the length of 5 units. Well, then EC will be 5 units because it'll be the same length. But DB, that whole diagonal DB, will not be the same length. So let's say that's 11. Well, then DE is 11, so EB must be 11. So important to know they're not the same length. Okay, let's solve a problem now. So it says in parallelogram ABCD below, we can see ABCD, it's a parallelogram. EB bisects angle ABC. So if it bisects it, it cuts it in half. That's important to know. This is important to know. It bisects it, so it cuts it in half. And they give us that angle A is already 40 degrees. So if A is 40 degrees, we know that C is, because opposite sides, opposite angles in the diagonal will be congruent. And just like we did before, you should be able to figure out angle D and B. What do you think they are? Pause if you need to. Well, remember, we need 360 degrees, and we already have 80 degrees. So we just subtract that, and we'll get 280 degrees. So D and B are congruent, because opposite sides are congruent. So we have to just divide 280 by 2. So we know that D would be 140, and then B has to be 140. Got that? Now, rewind if you need to. Let's go to this one now. It says that EB bisects it, so it cuts it in two. If it cuts it in two, that means this angle will be 70, and that angle will be 70. And we're almost there. Remember, quadrilaterals have to be 360, but we have a triangle here. And the triangle is 180 degrees. That's what it sums to. So if we take this line over, we make see this triangle right here. Just make a straight line using my kindergarten skills. So we have a 70, a 40. We're missing another 70 to make 180. But we want to know the measure of BED. We want to know right here, this question mark. What is that? Well, remember, we have a straight line here. Draw a straight line. Right? We have a straight line here. So straight lines equal 180. So if we have 70 here, this has to be 110. 110 and 70 is 180. So the measure of BED is 110 degrees. All right, go back if you need to. Let's look at another one. All right, this one looks convoluted. Let's look at it. It says quadrilateral EBCF, and remember it says quadrilateral. You know, parallelograms are quadrilaterals, but you can see that EBCF, this whole thing is not a parallelogram, so watch out right there. And we have AD, but we can see a parallelogram here, right? Here's a parallelogram. Just using my kindergarten skills again, trying to bring it out. All right, so we have a parallelogram here. And it's saying that angle E is 62 degrees, so let's just write 62 degrees in here. Angle C is 51. Remember, if C is 51, then A is 51, because they're opposite angles in a parallelogram. We're trying to find the measure of FHB. Right, so we'll use a different color. We want to know F, just going straight up, FHB. We want to know that degree over there. So another piece of information that's very helpful is this right here. It's saying EB, E and B are congruent to F and B. That means this triangle that we see here, EBF, this triangle is an isosceles. So if that's 62 degrees, well then this has to be 62 degrees. And then we know what B is. What do you think B is? Well, we got to get 180 degrees. So what's left? B has to be 56 degrees. So we're just putting in all the degrees. We have another triangle here. So what could this missing one be? Well, we have 56, we have 51, and we're trying to get 180. That gives us, we need 73 degrees. So this will be 73 degrees. See if you're following the math. Now, if you remember alternate interior angles, right? Remember there's two parallel lines cut by a transversal, right? This transversal over here. Well, if this is 73 degrees here, then the alternate interior angles are congruent. That has to be 73. So remember, we have a triangle here, right here. We said that this one was 62 degrees, but remember it says here that EF and FH are perpendicular. So perpendicular lines will make a 90-degree angle. So this whole thing here, well, it's getting a little messy, but this whole thing over here, right? Well, not here, but this whole thing here, this right here is 90 degrees. But we already have 62. So what do you think's left? 28 degrees. So now we have 28 degrees right here. So we have 73, we have 28. Remember, we're trying to get 180. So that just leaves that H is 79 degrees. Remember when I said that EF and HF are perpendicular, that means this right here, not this part over here, is 90. So 90, 62 and 28 make 90. And now we know the degree. Go back if you need to. Well, that is parallelograms.